This is our second video graphing polar equations. In this video, we're going to graph a lemniscate in polar coordinates. So the graphs of r equal a plus or minus b sine theta and r equals a plus or minus b cosine of theta, where a and b are both positive, are called lemniscates. The ratio a over b determines the shape of it. So basically it's the same formula as a circle, except you're going to have a constant with it. And there could be a minus. So you're going to see when we graph these, they're kind of circle-esque. We always want to test for symmetry. Even if the directions just say graph, you're going to want to test for symmetry just to make your life easier. So let's test r equals 1 plus 2 cosine theta for the three symmetries, and then we will choose our theta values, get our points, and graph our polar equation. Three types of symmetry we're testing for: polar axis, the line theta equals pi over 2, and the pole. For polar axis, we're replacing theta with the opposite. For the line theta equals pi over 2, we're replacing both. And for the pole, we're just replacing r. Plugging in negative theta, we get r equals 1 plus 2 cosine of negative theta. Using our negative angle identity, we get that r is equal to 1 plus 2 cosine of theta. Remember, cosine of negative theta is equal to cosine of theta. This is our original. So our graph does display symmetry with respect to the polar axis, so that's top half and bottom half. Checking for symmetry with respect to theta equals pi over 2, we're replacing both. Our negative angle identity simplifies the right side to 1 plus 2 cosine of theta. There's no real simplifying to do on the left. We can try dividing everybody by negative 1. You may want to do this individually. R equals negative 1 minus 2 cosine of theta. That's definitely not our original. So this may or may not have side-to-side symmetry. And lastly, we're testing the pole, replacing r with negative r. This is the same thing we had at this point in the previous example, and we saw that that did not simplify. Oh, this one is also a maybe. All right, but that symmetry with respect to polar axis cuts our list in half. We know it's either top half or bottom half. So when I chose my theta values, I chose the top half. These angles coming from quadrant 1 and these from quadrant 2. I know they kind of share this one. And then we plug each of those theta values into our equation, r equals 1 plus 2 cosine of theta, to get our corresponding r values. So, right, we did r equals 1 plus 2 cosine of 0, and then 1 plus 2 cosine of pi over 6, and so on, and we got all of our answers there. Let's start plotting these points. Our first point, 3, 0. I always think it's so weird because you start with the angle first, you have to write the r first when you write it as an ordered pair. I always think that's weird. All right, so starting at angle 0, there it is. We're going to go out 3 rings right here. Our next angle, pi over 6. Remember, this is marked at 15 degrees, so we got to go 2 lines. At pi over 6, we're going 2.73 rings. Next, pi over 4, 2 rings, 2.41 rings. At pi over 3, we're going to our angle of pi over 2, we're going just 1. Moving into our second quadrant angles, 2 pi over 3. We have an R value of 0, so that puts us right on the pole. 3 pi over 4. Here we have an R value of negative 4.14. So since we have a negative R value, we're going in the direction opposite of our angle. So we're actually headed into the fourth quadrant, negative 0.4-ish. Our next angle, 5 pi over 6. Another negative R value, so we're going in the opposite direction, negative 0.73. And lastly, looking at our angle at pi, we have an R value of negative 1, so we're going 1 in the opposite direction right here. All right, so those are all our points from our table. We now want to turn our attention to what we discovered when we tested for symmetry. We see that our graph has symmetry with respect to the polar axis, which is our horizontal axis. We'll be able to get additional points by reflecting the points that we have about this polar axis. I'm going to put these reflected points in blue. So we'll start here on the right. This is going to reflect right here. And our next point. And our next point. And then these ones in the middle, they're going to reflect up. Let's erase this symmetry line and draw in our graph. When drawing in our graph, we should connect the points in increasing theta. And there we go.